Hello, today we are going to discuss multiple regression. Please recollect in our multiple lines video, we have seen how to draw the multiple lines taking one line as x-axis and other lines on y-axis. In video number 25, 26, 27, we have learned ANOVA, and also in video number 27, we have seen the multiple comparison. Now, the same commands we are going to use for our multiple regression, except a few changes. I have already started Anaconda, and then in Anaconda, I have started Jupyter, and in the Jupyter, this Python 3 has been started. And I have named this file as multiple regression. See, the main commands for multiple regression will be x. See, there are going to be many x's. x1, x2, all your independent variables. We can take one variable, independent variable, two independent variables, three independent variables. So x is sm.add constant x. This is going to be one command where we want to add the constant. If we don't want to add the constant, forget it, don't write this line. See, multiple regression, you may need the constant or you may not need the constant. Then the next, which we are going to create a model. Model is coming from sm.OLS, which we used in our multiple comparison also. Y upon x, and it is going to fit. Now we can make predictions as model.predict x if we want to make any model on predictions. Otherwise, you forget it, you don't write it. And then print model summary. In the model summary, everything will be shown, coefficients of the independent variables, R square, adjusted R square, Durbin-Watson, etc. everything. I'm just going to copy in my new cell the main commands, how to open the file, browse the folder, open the file, then select the variables x variable and y variable. Because x variables will be many, so we are going to create a list, and then this will be separated by commas, and then we will give the commands that it should count the items in the list. See, this ANOVA multiple comparison, we have taken up this ANOVA multiple comparison. The same commands I am going to copy it here, where I am going to import Tinker as TK, Pandas as PD, import math. In this program it is not required, but I'm just importing it. Import Seaborn as SNS, we don't need it. Import and NumPy as NP, we don't need it. Import matplot lib pyplot as PLT. I'm adding all these things. In case you want to do anything else, you can use it. So I'm just going to copy. So it will import everything. I'm just going to copy up to this so that it may see the columns from our sample, and I am going to write it here up to columns. Other things I am not going to write. And then above main commands, I'm just going to copy it. I will write it here, new cell, add a new cell, and I'm going to add a new cell, and then I'm just going to paste it. So I have just copied the same commands from ANOVA multiple comparisons up to the creation of the columns for our samples. So import Tinker, tkinter as tk, import Pandas as pd, import maths, import Seaborn as sns, import NumPy as np, import multiplot lib pyplot as plt, from SciPy import stats, import stats model API as sm, which we are going to use for our OLS model. From stats model dot formula API import OLS. So OLS is going to function as in the function in the regression. From stats model starts multicom import pairwise Turkey HSD. We don't need this actually, because that is used for our only multiple comparisons. So we are going to do as line, and then import all the functions from tk enter, and it will work on. And below this, see, you have listed this. First, it will ask you what is your y. So you are going to be input as invoice, your choice for y, and it is going to be a, and then this a will be converted into c, because it will be columns integer a minus 1, and y will become dfc. You can simply write down here also like as y is df calls integer a minus 1. And then it will ask you what is your choice for x, because your x's can be 1, 2, 3, 4. So it is going to be in the, you are going to put the lista, and this lista is a empty error, and which you are going to create it. And in the lista, all the things which are separated by commas will be put into the list. From list, it will count into samples. This we have all done in video number 24, 25, 26, 27. Calls df.columns calls is this. And then these commands which I have written it above here, I'm just going to copy it, and it will do our multiple regression. Okay. Paste. See, I have shown you, I have created this file where I have there are 20 observations. Expenditure, individual expenditure. I asked 20 persons, what is your expenditure? How much you spent? He said 5,000, 10,000, 16,000. So people said, and I asked them the income, what is your income? So he said that 12,000 rupees per month, 15,000 rupees per month. How much wealth you have got? Cash wealth, immovable, not immovable, immovable. So he says 2 lakhs, 5 lakhs, 2 lakhs, 1 lakh, 1 lakh, like this. Then I asked him qualification bracket. Are you in qualification bracket of 1, 2, 3? So 1 is say simple metric, 2 is say plus 12, 3 is graduate, 4 is postgraduate. So like this qualification cadre we have created. Then I have taken it as gender. Gender is female is 0, male is say 1. And if it is not gender, you can simply take it as any dummy. Dummy means company's policies, whether they were implemented or not implemented, such things you can write. So I am going to use this file for our multiple regression. So let me run it. Run. When it runs, it will import all the functional files, and I am going to take up test 11, which I showed you the file. In the test 11, will then ask me, you want expenditure, income, wealth, qualification, gender as y, dependent variable, x, independent variables. I'm going to take first, let me take first only income. So now these are the regression results. It is with the constant. These are the coefficients. Constant coefficient is 6.4631. Standard error is 4.015. T value is 1.610. P is 0.125. It is greater than 0.05. It means this constant is not statistically significant. But income coefficient is 0.4914. The p value is 0.000. It means this is less than 0.01. it means the income is statistically significant at 1% level. R square is 0.572. It means 57.2% of the variances of Y are explained by X, that is by income. Now, all other things like this 42.8, so they are just some outside things. So in our model, the mostly the error point is 42.8%. 8% is the error. Adjusted R square, when we use our observations, how many observations are there, how many variables are there, and we use those things with this R square, so then it becomes adjusted R square, that is 0.4548. Show you the formula after some time. Yes. Then F statistics is 24.01 and the probability for that is 0.00. It means the overall the model is statistically significant. Overall the model is statistically significant, but the error part is 42.8 and this constant is. Now let me run it again. Now I am going to take up another other variable, but constant. So you can say run it, run. I'm going to select the file test11, but it will be without constant now. It will ask me what are the what is your dependent variable. I will say expenditure, and what are the independent variables. I'll say 2 and 3. Let us say income and wealth, and then I will say enter, and this result is coming up. Now R square is improved. Now R square, when we have removed constant, R square is now 0.922. When we have added wealth with that, R square has improved it. You can simulate it with the first one step by step. You can enter income, then you can enter wealth also, then you can enter qualification also, then you can enter your dummy variables, gender also, whatever is there. Now here we don't have constant. Income is 0.5898 and T stat is 10.085. P value is 0.000. It means it is less than 0.01. It means it is statistically significant. Income is statistically significant for expenditure, but wealth P value is 0.233. It is more than 0.05. It means wealth is not statistically significant. Wealth is not statistically significant. See, omnibus is used whether all the coefficients are 0 or they are statistically significant combined way. Now in combined way, this is 0.167. We cannot reject the null hypothesis, which means all coefficients are 0. But though income individually is significant, but combined one is all 0. Let us run it again and put all the variables. Run test11. This is my file. Open, and I am going to choose now expenditure as dependent variable 2, 3, 4, 5 all, but mind it, there is no constant. If you want, you can add constant to it. We will run it. We can do it without constant. So this is, let us see the results. These are the results. Now this is with the constant. Constant is not statistically significant. Income is statistically significant because the value is less than 0.05, or you can say even 0.01. Wealth is not statistically significant, 0.414. Qualification is not statistically significant because the p-value is more than 0.05. Gender is not statistically significant. Only in this model, income is statistically significant. And overall model, because the p-value of the F statistics is less than 0.05. That is why the overall model is statistically significant. So, but Durbin-Watson is given here is 1.165. It is not meaningful here. The reason is it's not historical data. But for historical data, lagged values are taken up, And if it is Durbin-Watson is near 2, it means there is no autocorrelation. But if it is less than 2 or more than 2, then there is an autocorrelation. Dark barrier test is there whether this is normally distributed or not, because this value is more than 0.05. So it means data is normally. And then this omnibus means that all variables which are uh, there, they are probability is 0.784, more than 0.05. Null hypothesis. All coefficients are equal to 0. Combined, all are 0. Despite this, the income is statistically significant. But combined value says that they are all zeros. Now let us run it without constant. I can run it without constant. So I will just put hash before this, run, and we are going to take up this test 11, open. So dependent variable is 1, expenditure. Dependent variables are 2, 3, 4, 5. So now it is without constant. Income is statistically significant. Constant we have removed it. Wealth is not statistically significant. Qualification is not statistically significant. Gender is not statistical. But overall, omnibus says that all B's are zeros. So this R square is 0.93. Model is statistically significant. So these are the things which we can use it for even one variable, two variables, three variables. So these results are shown by this. Our new commands are simple. New command is I have created an array model and I'm using sm.OLS y upon x. Y we have already created by a list. So is fitting. So we are not predicting anything. Prediction model is not there, but print model is model.summary. So we are printing this summary. This is basically the summary. Thanks a lot. Thanks for watching. Please see that you should learn all the commands from video number 1, because from video number 1 we started with the 2 lines, then we went on adding all the things. Now we are almost here with this, all these commands. For you, this is more than enough. With these commands you can do a lot of things. Only for any new things we are just adding 1 or 2 lines. Thanks for watching and wait for the next video. Thanks.